All right, so let's talk a little bit about battery drain testing. So, say you have one of those cars that's coming into the shop that customer says, hey, I parked this thing overnight, come out the next morning, the battery's dead, I have to jump start it, or maybe, it takes a couple of days, whatever the case is. So they bring it into you, and you have to figure out what's causing the battery to drain. First thing I would tell you to look for, or even question the customer if you can get them to be honest with you. Are they plugging anything into USB ports, to the power ports, to the 110 outlet, and are they leaving these things plugged in? Half the time they're not going to be honest with you. Some of them will, but you never know. I just dealt with a battery drain on a truck a couple of weeks ago. Exact same thing. Customer said, hey, I'm not leaving anything plugged in. He was questioning about that. We found 7 USB cables and some chargers in his truck, and one of those USB cables was trashed. It was junk. So that may have been a self-inflicted problem, but let's say none of that's going on and you do genuinely have a battery drain. So to locate your battery drain, you want to do a couple of things. You need to access every fuse panel in the car up front. So open all the doors, open the rear lift gate if it's an SUV, trip all the latches, take the key out, and never leave your scan tool plugged in either. If the scan tool's plugged in, it has the potential to keep modules awake, especially the body control module or the serial data gateway module, depending on what you're working on. So what I have here is a little GMC Terrain that has a battery drain. We're going to walk through how to diagnose that and how to find it. So you got all your doors open, your lift gates open, all your latches are tripped, the keys removed, the scan tool's unplugged. It's going to take a good 30 minutes for the car to go to sleep. Then you need to go to your negative battery cable and see how many amps of current drain you actually have. So this is pretty old school, but we used to use these little battery disconnect tool that you could put between the battery negative cable and the battery negative post, and had a little knob that you opened here to actually disconnect the battery, and you went one side of your meter here and one side of your meter here to see how many amps of current drain that you had. This really doesn't fit very well on most new cars. What you can do now, the GM guys out there, you've got access to a picoscope. The picoscope has an amp clamp that comes with it. It makes it nice and easy. And we will get some picoscope videos out there, hopefully this week. So be looking out for those. So I would take an inductive amp clamp. Here's one right here. And I can leave a couple of links in the description on where to find some of these. This one's a Central Technologies amp clamp. I believe goes up to 100 amps. When you're speccing out an amp clamp, make sure it does DC amps, not AC amps only, right? This one actually does have a little voltmeter as part of it too. I've had this for 10 years. It needs to read anywhere from 1 milliamp to, or at least 10 milliamps, all the way up to, I would say 10 or 15 amps. Doesn't have to have a huge range. Then the opening on the end of it's important. The size of that opening right there. This one's only 1/2 inch. I'd recommend getting one with at least a 1-inch opening here for like diesel battery cables. This one doesn't work very good on diesels. So first thing I want to do is, turn it on to DC amps, and I'm reading something on my screen right here. So hit that 0 button and 0 it out, and come over here and clamp it around your negative battery cable. And I have 2.2 amps of current drain. So 2.2 amps. It's fluctuating a little bit. It's down to a 1.4 amps at the moment, 1.5 amps. That is a very severe current drain. This battery's going to be dead probably under 2 hours. So we need to find that. So the best way to go about finding that, we need to isolate it down to a circuit and then to some devices on the vehicle. Best way to do that is to take your DVOM, whatever type of DVOM you have, make sure you set it to millivolts. You don't want to set it to DC volts. I had this one on DC volts. You want to set it to millivolts right there, okay? And then what you're going to do is you're going to measure across the backs of your fuses. So I'm going to take a spare fuse out of this little GMC here. Just for demonstration purposes, I would want to measure directly across the back of my fuse across each terminal, just like that. If I can actually get it to cooperate with me here. So I'd be measuring just like that, touching both terminals at the same time with the positive and the negative leads in the meter to see if I read any voltage on my meter. If I do, then I need to determine what that circuit or what that fuse is responsible for powering up on the vehicle and go start unplugging some things, see if I can isolate this current drain. Now, a lot of newer vehicles have 5 fuse panels, one under the hood, one on the left side of the dash, one on the right side of the dash, and if it's an SUV, one in the back. Depending on what you're working on, you need to locate all your fuse panels and have all those things accessible and have the car completely asleep before you start doing your diagnosis. And the backs of some of these fuses are very, very tiny too. They're very small, so an old school set of leads like this may not work very well. You may want to get a newer set of leads that are like needles, really, really sharp. I think these specifically are more for high voltage cars, but they'll work for what we're using them for today. So I'm actually going to switch over to these leads. If I don't get a good connection on the back of the fuse, if I have a poor connection, it will give me a false reading, and I will think I actually have voltage across the back of a fuse when I actually do not have voltage across the back of the fuse. So I'm going to take a couple of measurements here and watch this meter screen. Let's see what we get. So I'm just going across the backs of each one of my fuses. Still 0. So I'm going to check my fuses in my fuse panel here. I'm just going to start on one row of fuses and just work my way down the line until I go across every single fuse. And you see I had a poor connection there, so it's actually reading something. So let me go over here to my next row of fuses and let's keep testing. Nothing there. Work on my way down the row. There we go. I'm going to disconnect from that fuse and make sure I'm not tricking myself, make sure I actually do have a good connection. I got 18.8 millivolts across that fuse. So let's take a look at our fuse box cover and let's see what that fuse actually is responsible for powering up. So I'm going to take my fuse cover here and we're going to take a look at this and see what that fuse is responsible for right here in this row. And I can barely read this, so I'm going to take this off camera for a second so I can get my face in it. It looks like it's fuse number 9. Fuse number 9 in the panel is if I turn my lid over, they're nice enough to give us a label on this one. Fuse number 9 is my AC clutch. So I'm going to remove that fuse. And my current drain's going away. I'm down to 10 milliamps. Let me see if I can get a better look at that. I'm gonna put this on hold. When I removed my fuse, I went from 1.5 amps to 11 milliamps. 11 milliamps is going to be a normal current drain for this vehicle. The manufacturer's information tells me I can have up to 30 milliamps of current drain, depending on what's going on, if the OnStar module is going through an update or if it's awake, something along those lines. So 11 milliamps of current drain with a AC compressor fuse removed. Now, looking at the schematic on this vehicle, the fuse actually provides power to the AC compressor clutch relay. So I'm going to put the fuse back in. And when I put the fuse back in, I got a spike of 2.3 amps. Okay, so I put the AC compressor clutch fuse back in. You can see we had a 2.3 amp draw, so I removed the AC compressor clutch relay. The draw went away again. So I'm actually back down to 11 milliamps of current drain, which is normal for this vehicle. So I removed the relay. You can see it's got a wiring diagram right there on the side of it. So when the relay is de-energized, if you're looking at the switch side, pin 3 and pin 4 are connected to each other on this 5-pin relay. When the relay is energized, we move from the position number 4 to position number 5. It's possible my relay is shorted internally, so maybe we can do a test on it, see if we can figure that out. It's actually numbered right there on the bottom of the relay. So I'm going to test between pins 3 and 4 and see what I read, because right now I think I should read continuity, relay's de-energized, and then read between pins 3 and 5, and I should see out of limits or OL. So let's take a look at that, see what we get. So pin 3 to pin 4. So if I go, I'm having trouble holding on to my relay. If I go to pin 3 and pin 4 on my relay here, I actually have 0.7 ohms of resistance. But look here, when I go between pins 3 and pin 5, I have the same reading. This relay switch is internally fused shut. So that means when this relay is installed in my fuse box, you can hear that the AC compressor clutch automatically engages, and that 2.3 amp drain is going to suck that battery down in a hurry. So are battery drains always this easy to find? No, not really. And the reason for that, if you can get one that's currently draining the battery in your bay and run this test on it, just like we did here today, you'll find your problem. The problem is the intermittent battery drains. You know, something woke the vehicle up when it's at the customer's house. Something happens because the customer's plugging something into it, or it could just be happening just at random, but it happens when the customer has it versus when you have it at the stall, in your stall. When it's in your stall, it's intermittent, you can't duplicate it, it's going to be kind of hard to find. But if you can duplicate the battery drain, you can find the problem by checking DC millivolts across the back of your fuses to see what's powered up. Then you just need to go to your power distribution schematics to see what that fuse actually powers up and start eliminating your possibilities. Hope this helped out.